Hello, I wanted to talk briefly about the differences between cleaning, disinfecting, and sterilizing. Why do we care about these things and what do they mean? We might care about these distinctions because of our careers. For example, if we work in medicine, dentistry, childcare, or food preparation, or in microbiology. We would care about these things also in our everyday lives right now, especially because we're living in the middle of a pandemic and everyone is concerned about their health and safety. We also care about these things in the context of our laboratory and our class setting for this semester. So, the difference between these things is how much microbial contents could still be on the surface or in the liquid. And I'll share some examples with you of what these look like at home and in the laboratory. And I will share what you would expect your results to be if you were to sample them and incubate the sample in the lab. So for cleaning, this is the most microbial growth can still be present on the surface or in the liquid. Cleaning is defined by the Center for Disease Control as removing of visible soil. And it's important to clean things before you disinfect or sterilize them so that the cleaning that you do with the disinfectant later or the sterilizing you do later is more effective with less effort. So, an example of a method of cleaning at home would be dusting or removing the grease from the top of your stove after you've finished cooking. Um, an example of cleaning in the laboratory might be that if you spilled something, you would wipe it up with a paper towel quickly, dry it off, etc. So if you were to sample something that was cleaned and then inoculate a petri dish with it and incubate it, you would expect probably something will grow on that petri dish because you didn't see any visible soiling, but probably there are microbes present. The next level would be disinfecting. Disinfecting examples in your home would be if you use a disinfectant spray or wipes to clean up after you've been cutting raw meat on your cutting board, or perhaps if you used alcohol or peroxide on a cut. Examples of how you would disinfect in the laboratory would be that there would be a bottle of special disinfectant that we purchase for the lab that we expect you to use to wipe down the lab bench at the end of class every day. If you disinfect something, you need to make sure that you follow all the directions for that disinfectant and that you also are aware of what microbes a disinfectant has been tested on. The CDC defines disinfection as removing most or all pathogenic microbes from the surface or the liquid. So you would still, if you sampled it and incubate it, you might expect that you will find some growth on that petri dish later. The hope is that they will not be something that could infect a person. So, for example, disinfectants are often tested on whether or not they remove cold and flu virus. Sometimes they're tested on whether they remove common kitchen microbes like Salmonella or E. coli, or they might even be tested on common skin flora or molds. Um, but each disinfectant is effective for certain types of microorganisms, but not necessarily all. The next level would be sterilization. An example of sterilization at home is going to be a little more difficult to come by because most of the time we don't ever achieve this in our homes. The closest that we might get is if you have something that you've cooked in a pressure cooker. It might be sterile when it comes out. It won't be very long after you've opened the lid of the pressure cooker. But if you can things, the hope is that the contents of that can are now sterile. And you use a lot of things in your home that have been pre-sterilized for you at the factory. For example, adhesive bandages. Those come in little paper wrappers because they were sterilized at the factory. And when you open that wrapper or you break the seal on your can of canned goods, it's no longer sterile anymore. Sterilization happens in our laboratory whenever something goes into the autoclave or whenever something goes into an open flame or into the tabletop incinerators we use in the classrooms. You would receive media that's been sterilized. You would receive test tubes that are clean and empty and sterilized. But they will always be cleaned first, as in old agar would be removed from them or old broth would be removed from them. Then they would be sterilized in the autoclave. And then you might even re-sterilize the mouth of them after removing the lid by passing them through a flame again. Because once you take the lid off, any microbes in the air might come into contact with the surface again. When you sample a surface that is supposed to be sterile and you incubate that sample, there should be no growth whatsoever, no matter what temperature you incubate it, no matter how long you incubate it, no matter whether there is oxygen present or you incubate it without the presence of oxygen. Because if something is sterilized, there should be absolutely no microbial growth whatsoever. There should be nothing alive at all on that surface or in that container. It's an important distinction because if you have contamination, you don't know if it's the organism you were trying to grow or something that slipped in under the radar. So I hope that this helps you to understand these concepts just a little bit better for our class, perhaps a little bit better for your careers, and also for your everyday life when you're preparing food for yourself to eat or trying to keep yourself safe in a pandemic. Thanks. Have a great afternoon.